case, still working some more examples to find the limit of this particular function. The first thing we do is try direct substitution. We would get 0 plus 1 is 1. The square root of 1 is just 1. 1 minus 1 is 0. And in the denominator, we get 0. So we attempt a direct substitution. It's a pretty easy one to just do in our head. We find ourselves at indeterminate form, and we attempt to factor. That's the method we tried first. But there is nothing to factor in here. So in that case, we also have another method, which is the rationalization technique. You can either rationalize the numerator or the denominator, but in this particular case, the numerator is going to be the one that we're going to work with. And so we were going to rationalize this by saying x plus 1, and then we will have plus 1, which is what? Okay, so when we have that here, we're going to have like the conjugate idea. We're going to, whatever you do to the numerator, we also have to do to the denominator. So I have to multiply by that same term in the denominator. Now up here we have 4 terms, so we're going to FOIL this out. So let's do first term times first term times first term. What happens when you get the square root of something times the square root of something? Yeah, it becomes itself. So we're just going to have the, remember to bring this down. Good practice here. So we have x plus 1. That's for multiplying first terms. Now I'm just going to have square root of x plus 1 times 1. Alright, now I'm here with this term times this term. So inside, that gives me the negative of that same term. And then I'm going to do last. Negative 1 times positive 1 is negative 1. So we FOILed out the numerator. Now we want to distribute this x in the denominator. And that's just going to be x times the square root of x plus 1. Or actually, let's, instead of FOILing it out to get that x there, let's just do this. Let's just show multiplication in the denominator. Let's just show that we multiplied this term by this term, because we're hoping something cancels eventually, and that's going to make it easier for us to see if something cancels. What simplifies in the numerator? This term and this term, right? So I'm just going to be left with limit of, as x approaches 0, of our function that's left. So we have x plus 1 left, minus 1. We could have taken care of that. So here we can see that this plus 1 minus 1 is going to simplify, and you may not have to do it in quite so many steps, but for the first one I'm just going to have a paper trail of everything we have going on. So we have x. What's going to happen here? Yeah, now the x terms cancel. So I'm pretty much just doing one at a time, and if you'll let me, actually I'll have more room there. So the limit as x approaches 0. Now what do I have in my numerator? 1 is a placeholder, and then I'm just going to have the square root of x plus 1 plus 1. Okay, there's nothing else I can simplify, nothing else that cancels, so what do we do at this point? Attempt direct substitution again. So we would plug in our value, so we're going to have 1 square root of 0 plus 1 plus 1. And we simplify to 1/2. Okay, for number 10, if you'll write this one down, I'm going to help you get started, and then I'll let you attempt to work it by yourself and just check your answer. So when we're trying to rationalize, we're going to work with the numerator. So what will we multiply that by to rationalize? Square root of x plus 1 and then plus 2. Whatever we multiply in the numerator, we must also do the same in the denominator. Okay, so what you need to do now is FOIL out the numerator and simplify. FOIL out or just show multiplication in the denominator, and cancel anything that cancels until you get it completely simplified, and then try direct substitution again. Okay, so here's the solution. If you want to take a few minutes, these two terms cancel, and x 1 minus 4 is just going to be negative 3, or minus 3. These terms cancel, simplify, direct substitution, and we finish with 1/4. Okay, so the next type we're going to look at are involving trig functions. So we want to know the limit of the function f of x, which in this case is tangent x, as x approaches pi. Remember, pi is just a number. So using direct substitution, we can plug that in, the tangent at pi. But let's break that down even further. You can calculate that, those of you that have just had trig or you're quite familiar with it. But let's just give the definition of tangent in terms of sine and cosine. What's the tangent function? Sine of x over cosine of x. I could rewrite this as if this is helpful. And we attempt direct substitution. So when we attempt direct substitution, so let me rewrite. And now this one we're going to attempt direct substitution. So we're just going to have sine of pi over the cosine of pi. Now I have a unit circle pulled up somewhere. The sine at pi, so here we are at pi. What's the sine value? Sine is the y value, so 0. What's the cosine at pi? Negative 1. So when we come back over here, you told me sine at pi is 0. Cosine at pi is negative 1. So the limit of tangent x as x approaches pi is just going to be 0. Okay, we see another example. The limit of sine of pi halves times x as x approaches 1 is equal to, we'll try direct substitution. So that's going to be sine of pi when the x value is 1. Whoops. So that's just going to be, what is the sine value at pi halves? Let's look at our unit circle. Pi halves is here. What's the sine value? 1. Good, it's the y value. So our answer is just the limit of this function as x approaches 1 is 1. Limit as x approaches, limit of cosine of 3x as x approaches pi. Direct substitution, we'll attempt that first. So it's going to be the cosine of 3 pi. Now keep that in mind when we go around the unit circle. How much is it to go all the way around the unit circle? 2 pi, so really at 3 pi puts us over here, right? What is the cosine value at 3 pi? Yeah, good job. So that's just going to be negative 1. Alright, limit of the sine of x as x approaches 5 pi thirds. Direct substitution, we'll attempt that. So we want to know the sine value at 5 pi over 3. Go look at our unit circle. 5 pi over 3. Here, what's our sine value? Negative square root of 3 over 2. So, negative square root of 3 over 2. So use your unit circle to identify those particular values. Limit of our f of x function here as x approaches 0. So we'll have a 0 substitution in. So 0 squared minus 1. 2 minus the cosine of 0. This is just going to be negative 1. And that's going to be 2 minus, what is the cosine value at 0? Positive 1, good. So I'm just going to have negative 1 times 1. That gives us the limit of this f of x function as x approaches 0 is just going to be negative 1.